Hey guys, I have your notes here for section 5.5 day 2, and we're still solving trig equations. So your answers today should be theta equals, theta equals, theta equals, or x equals, depending on how your angle is represented. So today our solutions, the way we're solving these, heavy in factoring. I hope you're good at factoring. So usually when you factor, just a normal, like a quadratic or whatever, normally you make sure that your equation is set equal to 0. That's always the first thing you've got to do. Plan A, you look across your terms and you look for a greatest common factor to pull out, like undistributing. And if that's not an option, then you're going to try to factor into the product of two binomials. So I've got two functions here, two equations, two quadratics, whatever you want to call them. And I want you to factor each one. So this is what I would do. I would check across. I don't have a greatest common factor, so I'm going to factor into the product of two binomials. I'm going to automatically, since this is an x, I'm going to put an x here and an x here. And this isn't a hard one to factor. There is no coefficient on here besides a 1. So this should be an easy factor for you. We're looking for two numbers that multiply to make a positive 3 and add to make a negative 4. Those numbers are negative 3 and negative 1. So that's how it factors. And then what you do when you're trying to solve it, you take this binomial or this quantity or whatever you want to call it, you set it equal to 0, and you add 3 to both sides. Then you take this one, you set it equal to 0, and you add 1 to both sides. Those are your two solutions. Next one, it's set equal to 0. Two terms. Do you have a greatest common factor? Yes, you do. You have an x. Pull it out. So I'm going to pull an x out, and I pull an x out of x squared, and I'm left with a plain x, minus. Pull an x out of the 5x, and I'm left with a 5. I'm going to take this quantity, which is just an individual term, and set it equal to 0. Oh, look, there's a solution. And I'm going to take this quantity and set it equal to 0, and then I'm going to add 5 to both sides to get my other solution. All right, so it's going to get a little more complicated. We're solving trig equations. We're going to use factoring, solve for all values. We need to remember at the very end, put plus 2 pi n on all of our answers. So here we go. This is one term right here glued together with multiplication. This is another term. I have two terms. It's already set equal to 0. Is there a greatest common factor? Why, yes there is. They both have a sign. So I'm going to pull out a sign. When I pull out a sign from 2 signs squared, I still have the 2. And now I only have sign to the first. Minus, when I pull a sign out of a sign, I'm left with 1. Because remember, I'm actually dividing when I pull this out here. I'm dividing this by sign. I'm dividing this by sign. So I've got my two quantities. I'm going to take this one and set it equal to 0. You need to solve that one. I'm going to take this one and set it equal to 0. You need to solve this one. What happens? The moment you get this factored, and you create for yourself, you set this equal to 0 and you set this equal to 0, now you've created for yourself two equations that are just like yesterday's homework. So today's is just yesterday's homework with an extra step you're going to have to factor. So yesterday's homework, where is my sign fraction 0? Well, sign is 0 here and here. So my blue answers turn out to be 0 and pi. Set this one equal to 0, subtract 1, add 1. My bad. Add 1, divide by 2. Oh, changes my answer. There we go. Reference angle's pi over 6. It's positive, so here or here. My answer in quadrant 1 is going to be pi over 6. My answer in quadrant 2 is going to be 5 pi over 6. And then, oh, plus 2 pi n. Yep, can't forget about that. Next one. Where am I? Here I am. Set equals 0. It has 2 terms. Do they have a greatest common factor? Yep, they both have a tangent. Pull it out. So when I pull a tangent out of tangent squared, I still have a tangent to the first. Minus, pull out a tangent, and I'm left with 2. Set each quantity equal to 0. So set this piece equal to 0, set this piece equal to 0, and solve from there. Where is my tangent fraction 0? Well, my tangent fraction is 0 here and here. And where is, oh golly, where is tangent 2? Well, that's not on here. So you're going to need to take out your calculator. Do a tangent inverse on 2. And I get like 1.1071 blah, 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 blah. Okay, that's my reference angle. That's my reference angle. This is positive, so I need to look for an angle in quadrant 1 and in quadrant 3, because tangent's positive there, here and here. Okay, well, the angle from quadrant 1 is easy. It's just my reference angle. So 1.1071. The one from quadrant 3 is a little more challenging. So you've got to go all the way from 0 to pi plus a little more. How much more do you go into quadrant 3? You go this much more. You go the amount of your reference angle. So to get my answer, I'm going to go pi plus my reference plus pi. And I get 4.2487. There you go. Next one. Holy moly. This one's a little tough. Some of you are going to really struggle with this because you never did get really good at factoring. So now I have a coefficient on my sine squared. Game changer. So I've got this term, and this term. Do all 3 of them have anything in common? No. So I know I'm going to factor this. I'm going to try to factor it into the product of 2 binomials. Now, a little bit of factoring review. This equation, my sine is being squared. My sine is to the first power. This doesn't have a sign on it. This equation is very similar to 2x squared minus 3x minus 2. At one point, most of you should have been able to factor this quadratic equation. So, some of you do the a times c method. If you are an a times c person, do your a times c. So take your 2 times your negative 2 and you get negative 4. And then I don't know what you do with it after that. I'm not an a times c person. I hate the a times c method. Let me show you how I factor. I think I've showed you this before. So I'm gonna set this up. Here, let's pretend that I haven't done it yet. Right? Haven't done it yet. I'm gonna set this up into the product of 2 binomials. Ready? What do you normally do? First thing you normally do is you go x and x. You know why? Because a 1x times a 1x is a 1x squared. Well, I don't have a 1x squared, I have a 2x squared. Whatever goes here and here has to multiply to make 2x squared. Here's pretty much my only option. I think I need a 2x and a 1x, don't I? Isn't 2x times 1x 2x squared? Okay, now I need numbers that go here and here. This is a 2. So I think my only option is put a 2 here and a 1 here, or a 1 here and a 2 here. Let's try that. And this goes really fast once you get the hang of it. It's going to take me a while. But anyway, okay, so do these two multiply to make this? Check. Do these two multiply to make this? Check. I know one of them has to be positive, one of them has to be negative. What about the 3 in the middle? The 3 comes from the outer and the inner combined. So can you do any combination of a 2x and a 2x? Can you add them? Can you subtract them? Do either of those combinations get you a 3x in the middle? No. Maybe I put them in the wrong place. Why does their place matter? Because whichever one goes here gets multiplied by a 2. So swap them around. This times this, check. This times this, check. How about your outer and your inner? Well, my outer gets me a 4x, my inner gets me a 1x, 4x, 1x, 4x and a 1x. Does a 4x and a 1x combine in any way to get me a 3x? Yes. That's where I want the 1 and the 2. Now we've got to figure out which one has to be negative and which one has to be positive. I want more negatives left over. I want my 4x to be negative. Put a negative on this 2. Put a negative on this 2 and a positive on that 1, and it's factored. Or you would have used the A times C method, whichever one works for you. So I'm going to take this, 2x plus 1 and x minus 2, factor it now using my signs. So this, instead of 2x plus 1, I'm going to write 2 sine plus 1. And instead of writing x minus 2, I'm going to write sine of theta minus 2. Whew, that was the hard part. Because once you've got it factored, set this quantity equal to 0, set this quantity equal to 0, and, you've got it, right? So, subtract 1, divide by 2, reference angle, here. My blue answers turn out to be pi over 6, 7 pi over 6, and 11 pi over 6. And this was kind of funny how this worked out. Set that equal to 0. My sign fraction is 2. Nope. My sign fraction is never bigger than 1. So this doesn't produce answers. This one did produce answers. And plus 2 pi n plus 2 pi n. Now, just be careful. If you have a nope and some answers, make sure you circle your answers. You're not telling me there aren't any answers at all. There just weren't any answers from that side of my solution. I ended up with 2 answers, just not 4. So these are good answers. Okay, I think while we're on the factoring kick, let's go ahead and do the ones on the back. The ones on the back are going to cause you a little bit of trouble because they're not all in one. They're not all one trig expression. So I've got some sines and some cosines and sines. You're not going to be able to factor these if you've got a mixture of trig. We need to get it to one type of trig in my whole equation. So I got 1, 2, 3. I've got 3 terms, 2 of which are a sine. So I think I want to replace this and make it more similar. Take out the sine squared, make it more similar to what I have here. So what can you replace cosine squared with so that it fits in better with your sines? You can replace cosine squared with 1 minus sine squared. So that's what I'm going to do. I'm going to leave this the way it is. I'm going to leave this and leave this. and I replaced this with my green parentheses. See the minus that's still in front of it? I took a 1 term and subbed in a 2 term, which means I need parentheses around it. Okay, everything else stayed the same. I'm going to distribute my negative. That becomes a negative, that becomes a positive. Check that out. Front one stayed the same. This one stayed the same. The 0 stayed the same. Now, here's what I'm going to do. I've got a sine squared and a sine squared. I have a plain sign to the first power, and I have a -1 that doesn't have a sign on it. I'm gonna collect like terms, and I'm gonna rearrange so that it looks the way I want it to when I get ready to factor. All right? So I collected my like terms, and I put those out in the front. My sine squareds are in the front. My single sign is in the middle, and then my term without sign on it is in the back. And again, this is going to be, do they have anything in common? No. Factor into the product of 2 binomials. Careful, you got a 2 out there. I just showed you how to do this. So I'm going to factor these into 2 sine plus 1 and sine minus 1. Set them equal to 0. Solve each one. I end up getting 3 answers. And, oh wait, do they need a plus 2 pi n? No, they do not need a plus 2 pi n because the directions said, whoa, keep it within 1 revolution. Next one. Oh, this was interesting. Get it all to cosine or get it all to secant? I prefer cosine. So I'm going to turn this into cosine. Here I go. Oh, just kidding. I set it equal to 0 first. That's a good thing to do. Now, turn that into cosine. So I got 2 times 1 over cosine. Looks like this. All right. This is really hard to solve because you've got a fraction here with your cosine. You don't have a cosine squared. How on earth are you going to factor it? So what I'd like you to do, I really don't want this fraction here. How do you make a fraction not a fraction anymore? You multiply it by its denominator. So I would like to multiply this fraction by cosine. That's not exactly legal unless you do the entire equation by cosine. The entire equation, left side and all the terms on the right side. I'm going to multiply everything by cosine of theta. Everything. Ready? What's cosine times this? 2. Because my cosines cancel. What's cosine times this? Cosine squared. What's cosine times this? Cosine. What's cosine times 0? Still 0. Ready? I need to do a little rearranging. Cosine squared needs to come out to the front. Oh my goodness, I hate factoring when my leading coefficient is negative. So here's what I'm going to do. I'm going to do 2 things in one step. I hope I don't lose you. I'm going to rearrange. I'm going to put this in the front, this in the middle, and this in the back. And I'm going to multiply everything by -1. I do not want my leading coefficient to be negative. Don't like it. So I'm going to multiply that by -1, multiply that by -1, multiply that by -1. And then it factors, and I can solve. And it turns out I only got 1 answer this time. Yep. I didn't get an answer from that side. I only got 1 answer from this side. Okay, last one on the back. Ooh. Personally, I prefer tangent over secant. However, I can't turn a secant into a tangent. I can only turn a secant into like a 1 over cosine. Well, that doesn't help. Then I've got tangent and cosine. So instead of trying to turn this into tangent, why don't you try to turn this into something involving a secant? And you've got that. You've got those Pythagorean identities down at the bottom of that paper. And I think the substitution for tangent squared is secant squared plus 1. So this, nope, it was secant squared minus 1. Just kidding. So this turns into this. And then same, and I moved the 1 over. Now I'm going to collect my like terms. One, two, three. 3 terms. Do they all have something in common? No. Let's put them in the product of 2 binomials. Okay? And I'm going to set each piece equal to 0. I'm going to add 2 over here. I'm going to subtract 1 over here. And then I'm going to say to myself, you know what? I don't like working with secant. I'm going to upside down both sides of my equation. I'm going to upside down secant, and I get cosine. I'm going to upside down -2, and I get -1/2. I'm going to upside down secant, and I get cosine. I'm going to upside down -1. Well, that's just -1 still. So there's when I upside down everything. And then I'm going to do my reference angle, my quadrants, so on and so forth. Unit circle. And I get 2 answers out of this one, 1 answer out of this one. So it turns out I got 3 for this. Okay, now let's go back and hit that quadratic formula. So this one doesn't involve factoring. This one's, I think it's a little challenging. Keep in mind, when you use the quadratic formula, you're solving for x. Why? Because normally your quadratic looks kind of like this. Your x is what's being squared. And we set up our quadratic formula. Our quadratic formula gets us this. But this time, when I use the quadratic formula, what's being squared? Well, cosine is what's being squared, and cosine is what's here. So really, when I do my quadratic formula, I'm not solving for x. When I do opposite of b plus or minus the square, I'm actually getting the cosine of x. So, watch how I set it up. I've got a is 4, b is -2, c is -1. Ready? I'm going to write out my quadratic formula. When I do the formula, I'm getting cosine of x. So cosine is equal to opposite of b plus or minus blah, 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 blah. Cosine of x is this. And I get 2 answers out of this. I do 2 plus radical 20, and then I divide by 8. And I get some yucky decimal. And I do 2 minus radical 20 divided by 8, and I get some yucky decimal, right? I get 2 yucky decimals. What are those yucky decimals? Those yucky decimals are my cosine fractions. Let me say it again. Those yucky decimals are my cosine fractions. So let's work on the 2 plus version. Ready? Let's do the 2 plus version. So 2 plus radical 20 over 8. So I get cosine of x equals this as a decimal is approximately this. This is my cosine fraction. I want the angle. Okay? So you do a cosine inverse on your calculator. Now, the thing I like about this first one, this one's positive. When you do a cosine inverse and this is positive, where's your answer going to come from? When you do this on your calculator and this is positive, you're going to get an answer. You're going to get an angle in quadrant 1. Is that what you want out of a reference angle? Do you want a reference angle in quadrant 1? Absolutely, you want a reference angle in quadrant 1. So I'm going to do this with my answer, and I get a reference angle of, I forgot, oh, no, there it is. approximately 0.6283. That's my reference angle. That's in quadrant 1. Back up. Wasn't my cosine fraction positive? Since my cosine fraction was positive, I really want an answer here and here. Okay, so this was positive. I want answers here and here. I did cosine inverse. I got a reference angle. This is my reference angle. What's one of my angles in quadrant 1? Good, that was a trick question. What's my answer in quadrant 4 if this is my reference angle? Well, how do you get an angle in quadrant 4? You start here, you go all the way past pi, and you go all the way around to 2 pi. Just kidding, no you don't, you stop short. You go all the way around, you stop just short of 2 pi. How much short do you stop? It's your reference angle. So to get your quarter 4 answer, I'm going to go 2 pi minus reference. 2 pi minus my reference, and I got about 5.6549. Those are my two answers that came from 2 plus radical 20 over 8. Holy moly, now we got to do 2 minus radical 20 over 8. Okay, it's okay, because I might have lost you during the first one. We're going to do the same thing again. Ready? 2 minus radical 20 over 8 gives me a yucky decimal. What is it? It's my cosine fraction. It's my cosine fraction. Now, I know that I want to do a cosine inverse on it. However, I need a reference angle, right? I need a reference angle because that's negative. Where are my angles going to come from? A, S, T, C. My angles are going to come from here and here. How do I get an angle in quadrant 2? How do I get an angle in quadrant 3? I need a reference angle from quadrant 1. I need a reference angle from quadrant 1. If you do a cosine inverse on a negative, do you get an answer in quadrant 1? No, because your calculator knows it's semicircles. If you tell it to do a cosine inverse, it's going to think of its semicircles. You don't want it to. You want an answer from quadrant 1 because you know you need to use that as a reference angle. So I'm going to change this. I'm going to multiply this by a negative 1 to turn it positive. Then I'm going to do cosine inverse on my positive yucky fraction. What's that going to give me? It's going to give me a reference angle in quadrant 1. Now that I have my reference angle in quadrant 1, how do I get my angle in quadrant 2? Well, you want to go all the way to pi. Just kidding. No, you don't. You want to stop short. How much short from pi are you going to stop? That much. So quadrant 2, I'm going to go pi minus my reference, which is about 1.8850. Now I need quadrant 3. How do you get an angle in quadrant 3? You go all the way to pi and a little bit more. All the way to pi and a little bit more. How much more? The amount of your reference angle. All the way to pi plus a little bit more. And I get 4.3983. Whew, holy moly. I got 4 terribly yucky angles. All right. Good luck with that. I would imagine you might want to, if you miss them a few times in your My Math Labs or whatever, worksheets or whatever, hang on to it, ask me in class, or email me your work and ask me to find out where you went wrong, okay? I really want to help you through this. Good luck.